Today we will be working from chapter 16 in the Giancoli textbook, and we will be answering exercise C from 16-6. So our first step to answering this question is to read the problem. And this problem is asking us to determine the magnitude and direction of the net force on charge Q2 in figure 16-19A. Our second step is to identify the what. So what do we already know? And what are we trying to find? Let's start with the what do we know. If we continue reading the question, we know that the charge of Q1 is negative 8 microcoulombs. The charge of Q2 is positive 3 microcoulombs. And the charge of Q3 is negative 4 microcoulombs. We also know that the K constant is 8.99 times 10 to the 9th SI units. Also know that the R value, or the distance from charge Q2 to charge Q1, is 0.3 meters. So this is all information that we know. So now our third step is to choose the right equation. For this, we can use Coulomb's law, which basically states that the force is equal to the K constant times the absolute value of Q1 times the absolute value of Q2 over R squared. So since we are trying to find the force between points 2 and 1, we can use F21 equals K constant absolute value of charge Q2 times the absolute value of charge Q1 over R squared. And as we've already mentioned, R21 is equal to 0.3 meters. So we can just plug all the numbers that we know from the what do we know section and put that into the equation to get an answer. It is also important to note that a micro is equal to 10 to the negative 6. So now that we have the full equation written out, we can plug these numbers into our calculator to find the value. I'm also adding this black negative in front of the 8.0 times 10 to the negative 6 coulombs, as this can be used later in the problem to identify the direction. After plugging these values into my calculator, I get an answer of 2.397, which can be rounded to 2.4. So the force of 2 on 1 gives us 2.4 newtons. And then I'm putting the negative value in front of this as well, just so I can keep track of direction. However, we're not just done yet. We want to find the value of the net force. So, while we already have the value of F21, we now need to find the value of F32. So basically, our new equation will be K constant times the absolute value of Q3 times the absolute value of Q2 over R squared. And this time, R will be the distance between charge 3 and charge 2. I will now refer to the what do we know section and plug in the values that we were given into this equation. I'm adding a negative sign in front of the 4.0 times 10 to the negative 6 coulombs, again for direction purposes. Now that I have the full equation, I can plug all of the numbers into my calculator to find the value of F32. I am given a number of 2.697, which can be rounded to 2.7. In order to find the net force, I can use the equation F net equals F of 2,1 plus F of 3,2. So if I plug this in, I can get F net is equal to negative 2.4 newtons plus 2.7 newtons, which gives us a value of 0.3. So our net force is equal to 0.3 newtons. But we also need to determine the direction. Because of the negative signs, we can see that the forces are attractive, so Q2 is moving to the right. So our answer ends up being F net equals 0.3 newtons to the right. And that, my friends, is our final answer.